Hi friends, welcome to the Unit 2 Day 9 notes. This one's over even and odd functions in the difference quotient. With this particular set of notes, it's going to wrap up Chapter 2. This really is the bridge here in this notes into some calculus ideas. Don't worry, we're not getting into calculus. As I said, it's the bridge to it. So we'll talk about that a little bit. First, let's jump into even and odd functions. So a function is an even function if all values of f of opposite x equals f of x. So for when you plug in a opposite x, you end up back with the original kind of function. This type of function is always symmetric to the y-axis. And if you think about just kind of a basic even function, y equals x squared, that's going to be your parabola or your u-shape, and that is symmetric across the y-axis. So that would be kind of reflected or mirrored across, so that's a way to think about that. A function is an odd function if you plug in opposite x into your function and you get the opposite of f of x for all values, for all x in the domain of f. So this type of function is always symmetric. We call this the origin. Really what's happening is that it's symmetric to some sort of y equals x or y equals opposite x, or y equals opposite x. Really, what happens is you have a reflection across both the y and the x-axis. Determine whether the functions are even or odd, or neither, using algebraic methods. Then you can check your answer graphically. So what I mean by this is just plug it into your GCD. Plugging into your graphical display calculator, and then you can see what it looks like. So for this one, what we're going to do is we're going to plug in opposite x wherever we see an x. So we have f of x equals opposite of opposite x, parentheses, cubed. Remember, whenever we plug in or substitute a value, we have to put parentheses around it to show that we are plugging or substituting it in. And then 2 times opposite x. So if I simplify this, I have opposite x cubed. Well, that's going to retain that negative value, and the opposite of that is going to be a positive x cubed. And then here, 2 times negative x is negative 2x. You can see that I've changed all signs. All of the signs changed. This sign changed, and this sign changed. So since all of the signs changed, then this is a odd function. All the signs changed. For number 2, this one's y equals, again, parentheses, opposite x to the 5th, minus 2 times opposite x cubed. So here, opposite x to the 5th is going to be negative x to the 5th, and then this is going to be plus 2x cubed. Again, all of the signs changed, so this is going to be an odd as well. But now you're kind of seeing a pattern with these. If you look at the powers of the degrees, that's sometimes an indication that, yes, it's actually going to be an even or an odd function. It's not always the case. There's a few things that break that rule. Understanding how that rule gets broken is important. Number 3, here we have f of x is equal to, so plugging in opposite x, I'm going to have 0.5 and then opposite x to the 4th, minus 2 times opposite x squared, plus 6. When I raise a negative variable to an even power, it becomes even. It becomes positive. And so here I have nothing really changing with those values. And then 6 doesn't change as well. So this is actually even, because when I plug in the opposite x for all of those, I end up back at my original. Those are the same. Nothing changed. A lot of students get confused with 6 because they want to say 6 has a degree of 1. And 6 doesn't have a degree of 1. Remember, 6 has a degree of 0. In fact, all constants have a degree of 0. If I had an x by itself, like this one here, remember that's linear, and that has a degree of 1. Number 4. So here I'm going to plug in opposite x to the 4th, minus 5 times opposite x, then plus 8. So here, opposite x to the 4th is just going to be x to the 4th. Here, though, I have plus 5x and then plus 8. So I had one thing that did change. That changed sign from a negative to a positive, so this is neither. Remember, for it to be odd, it has to be all, and then for it to be even, it has to be no sign change. So if you have just one sign change, then it is neither. h of x equals, so number 5, this is where that whole idea of degree kind of gets broken. It's because of this absolute value. If you think about whenever you plug in an opposite x into the absolute value, well, opposite x is just going to become x when you simplify. So here I have 0.75x squared, plus absolute value of x. So this is simplified to just being x at this point. Remember, we've plugged in this negative, that's simplifying to that, plus 4. So this is going to be positive, none of the signs change, so this is even. Then for the last one, a lot of students want to say that it's odd, forgetting that, that 9. Again, let's see what happens. So if I plug in opposite x cubed minus opposite x plus 9, these two do in fact change, but the 9 does not. So we have a some sign change, but not all, so that would be neither. Join me in the next video as we get into the difference quotient. Have a good day, friends.